Good morning, students. Welcome back to our lesson again. Today our lesson is about physiological properties of nerve fibers, then parabiosis, the effect of direct current, then some laws of direct current on excitable tissues. Here is our lesson plan. The nerve fiber, structure of nerve. See, here is a typical neuron, and it has normally cell bodies and processes. And processes, it will divide it into two parts. This is short, and you have many processes. It's normally called dendrites, and dendrites function is to receive impulses. And here, this is long process. It's called axon. Axon normally transmit impulses from the cell body to the axon ending. And here again we have myelin sheets. And between each myelin sheets we have a root of Ranvier. And neuron can classify to many types. For example, this one is kind of multipolar neuron. This is multipolar neuron because it has many polars. And again we have bipolar neurons, and it will normally exist in the retina. And again we have unipolar neurons. It will exist in the sensory neuron. And again, this is, I said, multipolar neuron. Again, this is a motor neuron. And again, by function, we can divide it into sensory neuron and motor neuron. And another name of sensory neuron, it is called afferent neuron, and another name of motor neuron is efferent neuron. Again, and can, because of is it exist or not myelin sheet, we can divide it in unmyelinated nerve fiber and the myelinated nerve fibers. And again here two properties, physiological property of nerve fibers: excitability and the conductivity. And excitability is the ability to generate an action potential, and the conductivity is the ability to transmit impulses through the nerve fibers. And again here, transmission of impulses through the nerve fibers, I said this is number one, it's unmyelinated nerve fiber, and this is myelinated nerve fiber, and through this non-myelinated nerve fiber, the impulses normally is transmitted continuously, and it has not any barrier. Here, this nerve fiber, it has myelin sheets, and between myelin sheets we have node of Ranvier, and this one can only transmit by kind of jump from this one to this one, and jump from this node of Ranvier to the next node of Ranvier, and we call it saltatory transmission. And this myelinated nerve fiber normally transmit impulses much more quicker than this non-myelinated nerve fiber. Again, here we have classification of nerve fiber. This classification normally is based on the diameter of nerve fibers. And A alpha is the most fixed, and C is the most thin. And because of this A alpha, it has a more fixed diameter, and its velocity of conduction is much more higher. And again, then we have a beta, gamma, delta, and then the diameter will become small, and velocity of conduction, again it will be slower, becomes smaller and slower. And phi is the most slowest nerve fiber. And you know, C, type C nerve fiber normally is postganglionic nerve fiber, and it's unmyelinated. And type B, it's type of preganglionic autonomic nerve fiber, and again it's myelinated. And A, all of A types is myelinated, and normally A alpha is sensory neuron normally. And again we have motor neuron is classified into the A alpha, and then we have a beta. It's normally it perceived from the Golgi tendon organs impulses, and again A gamma is perceived from ventral gray horn. And again here we have some laws of conduction of impulses through the nerve fibers, and the first one is the law of integrity of nerve fiber. It means if nerve fiber is damaged or cut or compressed, it cannot conduct the nerve impulses anymore. And again, its next one is the law of indifferent conduction. It means a nerve fiber that excited nerve fiber at its, if we excited nerve fiber at its middle, it can conduct the impulse in both directions. Law of isolated conduction, you know, it's and the nerve fiber conduct exclusively and independently the impulses, and the excitation or impulses does not diffuse in the next or adjacent nerve fibers. And again here we have a relative infatigability of nerve fiber. It's because of low consume of energy during excitement and the quick resynthesis of energy. And again here it said nerve fiber fatigued if it is placed in the nitrogen atmosphere. It's because of here is less oxygen and it cannot resynthesize the energy. And again one more important concept, it's called parabiosis. And here we have para, it means some near, and biosis, it means life, as near life kind of. It's a decrease of lability because of strong stimulation or chemical substance. And again here it said it has three phases, and the first one is leveling phase, second one is paradoxical phase, third one is inhibition phase. Here this one is leveling phase, then paradoxical phase, then inhibition phase. Kind of, if leveling phase, it means normally if we give the strong stimulation, the nerve fiber will generate more action potential or give a strong response. But during leveling phase, when we use some strong stimulation or chemical substance, it will give the same response to all of the stimulation. Then it's kind of opposite, vice versa, and if we increase the stimulus, it will give less responses. Then after the second phase, it will enter third phase. It's kind of inhibition phase. It will not show any response to this stimulus, and it means during this period nerve fiber cannot generate any action potential, and its liability is lowest. And again it said during complete parabiosis, excitation does not spread or does not transmit, and it will be stabilized in the area of irritation. It's called stationary excitation or fixed excitation. And again, here we have some effect of direct current on excitable tissues. We have polar laws of direct current, and here it says if the irritating effect can only be observed when the current is short-circuited and disconnected. And kind of short-circuited, it means connected and disconnected. The effect can only be observed when the current is connected to the direct current and the disconnected to the direct current. And when current is connected, the excitation occurs at the cathode end, and when it is disconnected, it happens at the anode end. And again, the effect of current during connected is stronger than the disconnection. And again, here we have some effects. The first one is cat electroton. It means it's increase of excitability and the conductivity under cathode because of the influence of direct current. And we have anelectroton. It means decrease of excitability and conductivity under the anode end because of the influence of direct current. And again, we have cathode depression. It is a decrease of excitability and conductivity under the cathode end because of prolonged exposure to the direct current. And again, we have a anode excitation, and it's an increase of excitability and conductivity under the anode end because of prolonged exposure to the direct current. And that's the end. Thank you for listening.